Okay? Right. So here, suppose this is a rocket. Now the basic underlying principle of a rocket is this. See, if you recall, you have experienced all this. While blowing a balloon, sometimes you blow a balloon for a birthday party or something, you want to decorate the room. So while blowing, half the balloon is already blown and all of a sudden it slips from the mouth. Then you find that the air gushes out in one direction and balloon moves in the opposite direction and immediately it falls. Have you noticed this? Air coming out through the mouth of the balloon in one direction, balloon recoiling in the other direction. So that is exactly the principle of jet propulsion. So instead of air, a jet propulsion, it ejects exhaust gases. It has fuel in the form of gasoline or whatever it is. Okay? Just like you have petrol, diesel in ordinary thing, it has gasoline. Gasoline is more refined form of fuel. Aeroplanes and all, they use gasoline in the form of fuel because petrol and diesel will not be that efficient. So it's naturally, since it is more refined, it is more costlier also. So once the fuel is burned, the exhaust gas is produced, mostly CO2, is ejected forcefully in one direction. That propels the jet or rocket in the opposite direction. How it happens, mathematically we'll see all the equations and all. So, jet plane is moving with the velocity v. Let us say the mass is already m, mass is m. At any time t, we are just discussing general time t, and exhaust gases are being ejected in the opposite direction in which it has to move. It has to go up, this exhaust gases have to be ejected in the downward direction. Okay? Now during a small time interval delta t, after a small time interval delta t, what will happen? Just imagine. The velocity would have increased by small value delta v because a small amount of exhaust gases, let us say delta m, has been ejected. Let us say the gases are ejected with velocity u. Is it clear? This much is clear? So at any general time, the mass of the rocket was m, it was moving with a velocity v. In a small time interval delta t, a small mass delta m